Here we are looking at example 2 from our 1.5 set of notes. Now we're asked, given this following function, x divided by x squared minus 9, we're looking at the one-side limit, specifically at what's happening at -3. Now this leads us to kind of conclude that there might be something happening there, maybe like a whole or vertical asymptote. So let's go ahead and just solve where this bottom is not equal to 0 and see what's going on. As you guys know, if you just add that 9 to both sides, then x would be not equal to plus or minus 3. So we are seeing, in fact, a vertical asymptote here because nothing canceled with the top. So this would be a vertical asymptote at -3 because that's, again, what we're specifically looking at. Now let's go ahead and look at the limits individually. If you think about it, we're approaching, just for this first one, A, we're taking the limit as x approaches -3 from the right side. So we're actually looking at numbers that are larger than -3. So you want to think about numbers that are larger than -3. So a prime example of this would be like -2. And a little trick here with this is if you were to throw in -2, just to see what's going on with this vertical asymptote, if it's going towards positive infinity or negative infinity, without necessarily graphing, if we go ahead and throw this value -2, which again is to the right side of -3, into our function, then we end up with -2 on top. Well, that's just a negative. And we really only care about the signs at this point. If you were to throw -2 in the bottom, you'd end up with 4 minus 9. That's a -5. But again, we just care that it's negative. A negative divided by a negative is going to come out to be a positive. And as a result, this should, since it's approaching a vertical asymptote at -3, it should be approaching a VA, or it should be approaching positive infinity as you approach that vertical asymptote. On the other side, you're approaching -3 from the left. So we have to think about numbers that are less than -3. So a prime example of this would be like -5. If we were to throw that into the function, we would end up with a negative on top over -5 squared is positive 25 minus 9 is going to be 16. But again, we really just care that it's positive or negative. He is positive 16. So a negative divided by a positive comes out to be a negative. Now keep in mind, you are approaching this vertical asymptote. And as a result, that's where we really see those infinities or negative infinities. And because our final answer came out to be negative here, it'd be approaching negative infinity. So again, pretty much the moral of the story here is you can actually go ahead and look and see where the vertical asymptotes are, and then throw in values that are to the right of it and to the left of it, and just seeing what kind of their signs are and how they play out. And then they tend to go to either positive or negative infinity. So these give us what the graph tends to do. However, it's not always going to be ironclad. And if you're thinking, well, wait a second though, we just used this technique, it worked. I mean, even if we were to pull up a graph of this, here is specifically that graph. We can see as you approach that -3, we have that vertical asymptote. It is matching what we were saying. Now here's the trick though. And again, this is what it tends to do, plugging those values in. However, what if we had some other function where we see something like this and it has a vertical asymptote at some x value, and on the left side you do all the plugging in and you see that it's going towards positive infinity, and that's all great, that's fine. But then on the right side you try throwing in a number and you choose the number right here, so some particular x value that you throw in, and you see that it's positive and you think it's going towards positive infinity. However, the graph actually goes back down and then towards negative infinity. So maybe it reaches some other x value and then it takes a sharp turn. And so that's why this method is really, really nice and handy to do without necessarily graphing. But it's not an ironclad method, okay? And this would really have to depend on the function. It does work a lot of times, but it's not 100% ironclad every single time, where you could just throw in numbers to the left and right and see if their signs are negative or positive infinity. But again, it does work quite a bit, but not ironclad. So again, though, that is example 2 from our 1.5 set of notes.